In this video, we'll break down the essential definition of terms under the principles of structural analysis and design. Let's begin. Yielding. A slight increase in stress above the elastic limit will result in a breakdown of the material and causes it to deform permanently. Statics is the branch of mechanics which studies the effects and distribution of forces of rigid bodies which are and remain at rest. Friction is a contact resistance by one body when the second body moves or tends to move past the first body. Strain energy is energy stored in a material due to its deformation. Modulus of toughness. It indicates the maximum amount of strain energy the material can absorb just before it fractures. Ability to absorb energy in the plastic range. Modulus of resilience. It represents the largest amount of internal strain energy per unit volume the material can absorb without causing any permanent damage to the material. Ability to absorb energy in the elastic range. Elasticity. It refers to the property of a material which makes it return to its original dimension when the load is removed. Ductility. It refers to the ability of a material to deform in the plastic range without breaking. Stiffness. The ability to resist a deformation within the linear range. Inverse of stiffness is flexibility. Toughness. Material's resistance to fracture. Hardness. Material's resistance to indentation. Ductile materials. Any material that can be subjected to large strains before it fractures is called a ductile material. Brittle materials. Materials that exhibit little or no yielding before failure are referred to as brittle materials. Homogeneous material. It has the same physical and mechanical properties throughout its volume, or material has the same composition at any point. Isotropic material. It has same physical and mechanical properties in all directions. Orthotropic material. It has material properties at a particular point, which differ along three mutually orthogonal axes.
Prismatic. All cross-sections are the same throughout its length. Creep. When a material has to support a load for a very long period of time, it may continue to deform until a sudden fracture occurs or its usefulness is impaired. This time-dependent permanent deformation is known as creep. Fatigue. When a material is subjected to repeated cycles of stress or strain, it causes its structure to break down, ultimately leading to fracture. Buckling. Lateral deflection that occurs when long, slender members are subjected to an axial compressive force. Strain hardening. When yielding has ended, an increase in load can be supported by the specimen until it reaches a maximum stress, referred to as the ultimate stress. Necking. Just after the ultimate stress, the cross-sectional area will begin to decrease in a localized region of the specimen until the specimen breaks at the fracture stress. Concrete is a mixture of water, cement, sand, gravel, crushed rock, or other aggregates. Aggregates. It is used in concrete may be fine aggregates and coarse. Center of rigidity. It is the point through which the resultant of the resistance to the applied lateral force acts. Center of gravity is the point where the object suffers no torque by the effect of the gravitational force acted upon it. Center of mass. It is the point through which the applied seismic force acts. Center of stiffness. The point through which the restoring forces of a system acts. Column. structural member has the ratio of its unsupported height to its least lateral dimension of not less than 3 and is used primarily support axial load. Corbel is a short edge beam projecting from a column to support a weight. Damping, the addition of energy-absorbing components into a structural building frame to reduce lateral deflections and lessen the stresses imparted into the frame when subjected to high wind or seismic forces. Eccentricity, it is the distance between the center of rigidity and center of mass.
Epicenter, the geographical point on the surface of Earth vertically above the focus of the earthquake. Focus, the originating earthquake source of the elastic waves inside the Earth which cause shaking of ground due to earthquake. Focal depth, besides the epicenter, it describes the location of the earthquake. Homogeneous, the material has the same composition at every point that the elastic may not be the same in all directions. Hooke's law. Stress is proportional to the strain within the elastic region. Orthotropic. The composite material exhibits elastic properties in one direction, different from that in the perpendicular direction. Poisson's ratio. The deformation of axially loaded members, the ratio of the lateral to the longitudinal strain is constant. Post-tensioning, stressing high-strength steel after the concrete has been cast and has attained sufficient strength. Pre-tensioning, stressing high-strength steel wires before concrete hardens. Proportional limit, it is the term for the value beyond which the stress is no longer proportional to the strain. Elastic limit, the greatest stress a material is capable of developing without a permanent elongation remaining upon complete unloading of the specimen. Modulus of elasticity, the slope of the straight line portion of the curve or the ratio of stress over the strain. Plasticity, a condition that, when there is already a permanent deformation, it continues to deform when a minimal load is applied beyond the elastic. Reciprocal of deflection, it refers to the rigidity of a structure. Reciprocal of stiffness, it refers to flexibility of a structure. Relaxation, loss of stress that takes place with the passage of time as concrete is held at a constant strain. Resilience, it refers to the ability of a material to absorb energy in the elastic range.
Resonance refers to the large amplitude vibration of an object or system when given impulses at its natural frequency. Natural period, time period of undamped free vibration of a structure. Intensity is a measure of the strength of shaking during the earthquake. Magnitude is a measure of energy released in an earthquake. Seismographs are instruments used to record the motion of the ground during an earthquake. Soft story, it is one in which the lateral stiffness is less than 70% of that in the story above, or less than 80% of the average lateral stiffness of the 3 stories above. Weak story, it is one in which the story lateral strength is less than 80% of that in the story above. Resultant determines whether the body will be in equilibrium or will have a varying state of motion. Story drift, it is the displacement of one level relative to the level above or below. Story, it is the space between 2 adjacent floors. Static, it refers to the force generated by a body at rest.
Story displacement is the lateral displacement of the story relative to the base. Out-of-plane offsets, discontinuities in a lateral force path. Diaphragms, rigid horizontal planes used to transfer lateral forces to vertical resisting elements. Shear wall, designed to resist lateral forces acting in its own plane, typically wind and seismic loads. Torsional shear stress occurs when the center of mass and rigidity do not coincide. Yielding, the material deforms considerably even with a slight increase in stress.
Toughness. It refers to the ability of a material to absorb energy in the plastic range. Yield stress. The stress at which there occurs a marked increase in strain without an increase in stress. Ultimate stress. The max stress a material is capable of developing. Rupture strength. The stress at which the specimen actually breaks. Water-cement ratio. It significantly influences the quality and strength of concrete. Young's modulus. It is the constant of proportionality that defines the linear relationship between stress and strain. Resilience. The property of a material enabling high impact loads without inducing a stress in excess of the elastic limit. Factor of safety. It is the ratio of the failure stress to the allowable stress. Failure. The condition that renders the load-resisting member unfit for resisting further increase in loads. Diagonal tension. The tensile stress that develops on the diagonal surface. Brittleness. Implies the absence of any plastic deformation prior to failure. Malleability. The property of a material enabling it to undergo considerable plastic deformation under compressive load before actual rupture. Dilatation. Change of volume per unit volume. Intensity. It is the oldest useful measure of an earthquake's strength, which is based on the damage and other observed effects on people, buildings, and other features. Dynamic. Forces generated by a body in motion. Anisotropic. Materials whose properties depend upon the direction considered. Corrosion. Failure of a metal due to repeated stress. Camber. A built-in upward curvature of a beam or girder to compensate for its deflection or sag.
Workability. It is the measure of how easy or difficult it is to place, consolidate, and finish concrete. Plastic hinge is the deformation of a part of a beam whenever plastic bending happens. Concrete pedestal is a compression element provided to carry the loads from supported elements like columns, statues, etc., to footing below the ground. Web local yielding assumes that the entire applied force or reaction passes through a critical area of web located at the top of the fillet that connects the flange to the web. Web local crippling is actually a local buckling that occurs when the web is slender. Plastic analysis is the analysis in which the criterion for design of structures is the ultimate load. Seismograph refers to the instrument used to record the motion of the ground during an earthquake. Magnitude refers to the measure of energy released in an earthquake. Intensity refers to the measure of the strength of shaking during the earthquake. Liquefaction refers to the state in saturated cohesionless soil wherein the effective shear strength is reduced to negligible value. Focus refers to the origin or source of the elastic waves inside the earth which cause shaking of ground due to earthquake.
Thank you for watching. If you found this helpful, don't forget to like, share, and subscribe to Engineer CM Solutions for more civil engineering tutorials. See you on the next video.